Welcome to RSET Online. I am KrishnaKumarKP, Assistant Professor, Department of Applied Electronics and Instrumentation, Rajagiri School of Engineering and Technology. Today I am here to introduce you the subject Instrumentation for Agriculture, AE365 of Kerala Technological University. It would be more interesting to start the subject with a little bit of history. Till 10,000 BC, our ancestors were mostly hunters and gatherers. So around 9500 BC, we started gathering wheat, flaxseed, chickpeas, etc. and learned to cultivate it somewhere in the banks of Nile River and in early Mesopotamia, the present day Israel, Lebanon, and Syria. Parallelly, the rice was domesticated in China around 6200 BC. So, the process of farming evolved parallelly across different continents. Okay. Now, when we come to the evolution of farming, earlier farming was done by human beings itself. Then later came animal assisted cultivation, domestication of cattle. We can make use of cattle for ploughing the field, carrying the harvested rice or the harvested agricultural products. Around 1800 AD started mechanized farming. Then in 1950s came the revolution of biotechnology and genetic engineering, which revolutionized the production and eradicated the food scarcity problems. Now the modern trends in farming is AI and IoT. AI stands for artificial intelligence and IoT stands for Internet of Things. So we can better predict the yield and demand. The supply versus demand chain can be very well predicted using these frameworks. Okay. Now coming to the objectives of farming. The main objective of farming is to get high yield, minimize input overhead, resource like fertilizers, pesticides, man and machine hours, etc. Minimize pre and post harvest losses, preservation of foods, and finally planning and optimization including weather forecasting, market value of the produce, etc. So these collectively forms the objectives of farming. Of course, I have only illustrated few points. Apart from this, we do have many other objectives also depending upon the geographical locations, etc. In this timeline diagram, you can see around 30,000 BC, we began artificially selecting wools because wools were associated with human settlements to eat the waste products dumped by human beings. Wools were there, or the remains of the food left over by human beings were eaten by the wolves. Then around 7800 BC, there came artificially selected crops, or the actual agriculture started at somewhere in that point. Later, during 1973, first genetically modified animal was created, and subsequently the Food and Drug Administration authorities sanctioned genetic engineering to produce both pharmaceutical as well as agricultural crops for the human society needs. Shown in figure is a genetically modified chicken which is high yielding in nature, which grows in a very shorter period of 40 days, less than 40 days, and the farmer can sell the chicken into the markets. Okay. Now coming to the point, modern trends. The modern trends of farming include greenhouse farming, which is very well suited for cold countries like Canada, Iceland, where we create a greenhouse covered with glass or other transparent materials. So inside that we can grow crops, as well as the bottom side can be used to cultivate fishes. So one problem associated with this greenhouse is heating requirements, and also illumination requirements. So what they do is that they control the carbon dioxide level by monitoring, and thereby adjust the temperature of the greenhouse. Additional heat required is supplied through heaters. So in this way, more of the regions in the Arctic Circle or subarctic circles can be made into production farmhouses. Now, next, when it comes to food processing technologies, we are with the most advanced stage now. We have less harming preservatives, food colors, mostly organic based, and we have methodologies which is less toxic to human beings, but yet it preserves the food for longer times. Organic methods. Uh, this is more associated with organic farming also, where we can minimize the pesticide, and you know we can come up with certain processing technologies so that the food can be preserved over longer duration. I'll tell you one example where I went to Synthite, um, which produces spice extracts that can be used to flavor foods like Maggi noodles. Now, when we want to ship the meat products to some countries which is far located, we need to store the product in chilling plants or deep freezers, and a lot of instrumentation is associated with this kind of chilling plants, where we need to regularly monitor the temperature, and we need to cool the system in order to preserve the meat or fish. And when it comes to AI and IoT based supply chain, uh, things go much smarter. We can optimize everything like storage, then dispatch, harvest. Everything will go in a chain which is very well optimized, so that the end user or the customer will get the product at the earliest uh, or the least time period required for transportation and other kind of processing, whereby minimizing the storage of the material. Okay. Now, when it comes to measurement and control for agricultural purposes, the main thing which we do is measure the properties of soil, like pH level and fertilizer level, nitrogen level, etc., and the amount of organic materials present in the soil, which is very necessary for the plant growth. Then the next important parameter is the amount of irrigation. Amount of irrigation is very important because over irrigated plants, the roots will die and will subsequently affect the yield. The same is a problem with under irrigation also. Means plants won't get enough water needed for their growth. Now, the amount of CO2 present in the atmosphere. CO2 is basically a gaseous fertilizer. Uh, you know, there's a story that the greenery in Amazon forest has increased over the past 100 years due to the more CO2 emission. There is a saturation in the growth limit of the forest. Means the forest is overcrowded with trees and other plants. So CO2 is a gaseous fertilizer, and CO2 has importance in greenhouse farming in controlling the temperature of the greenhouses, which we will see later. Now, in order to predict the crop damage, we need to monitor the weather, and accurate prediction of weather is very important in terms of assessing the losses or damages that creates to the crops. Finally, we need to automate the machineries associated with the whole process, like planting, harvesting, processing machines, etc. One example is cotton picker machine, which picks the cotton and it stores into the bucket behind the vehicle. Okay. With this, I am coming to an end of the session. The reference is shown in the slide. The viewer is encouraged to go through the reference. So we'll see in a next session. Thank you.